Alright, this is the Unit 5 test study guide for Section 1 vertex form. I've already gone over this with the class, but I'm going to go over it for the video. Vertex form, H and K. H represents the X value at the vertex. K represents the Y value at the vertex. So you'll see right here, Y equals A parentheses X minus H squared plus K. So we need to identify H and K. Whatever H is, that's the X value at the vertex. Whatever K is, that is the Y value at the vertex. So looking at A, 4 is H, right? Remember, it's X minus H, so H is always being subtracted. So you do need to kind of look at that sign and change it. And then K is 9. Looking at B. B, this time is X plus 8. Well, remember, it's X minus H. So it's actually X minus negative 8. X minus negative 8 becomes X plus 8. So it's going to be negative 8, comma, negative 5 there for B. Negative 8, negative 5. C, notice with H, H is being added or subtracted from X, and then it is being squared. I should say H is being subtracted from X, and then it's being squared. So here, we need to ask ourselves, what is being subtracted from X? Nothing is being subtracted from X. The 2 is being multiplied, or X squared is being multiplied by 2. But nothing is being subtracted from X, so the X value at the vertex, or H, is 0. Now, what is being added or subtracted to the squared term? That's K. That's 9 in the situation. So 0, 9 is the location of the vertex of C. On D, X plus H squared, what is being added or subtracted from X before it is being squared? Or I should say, what's being subtracted from X before it's being squared? Negative 8 is being subtracted from X before it's being squared. And then the Y value, there is nothing being added or subtracted out here to the right. So 0 is K. Moving on to number 2. Number 2 says, is there a stretch, compression, or neither? This involves A. We need to identify A, and we need to figure out what A is. And we'll talk about what a stretch or compression does to the parabola graphically. Does that stretch / compression make the parabola open wider or narrower? Does the parabola open up or down? So looking at letter A in the parabola is 1/4. A in the quadratic function is 1/4. So we got to take the absolute value of this. The absolute value of 1/4, that is equal to 1/4. If the absolute value of A is less than 1, like it is here, if the absolute value of A is less than 1, that's going to be a compression. So this is a compression. And what does the compression do to the parabola? It makes it wider. So this will appear to be wider. And finally, does the parabola open up or down? A is positive. If A is positive, it opens up. If it were negative, it would open down. So compression, wider, and up. Looking at B. B, the absolute value of negative 1/2 is 1/2. So the absolute, that should be the absolute value of A. So the absolute value of A, again, is less than 1. So that is a compression. And the compression makes the graph wider. And go ahead.
Hi, this is the front office. Can you please send Ishmael to Ms. Bell's office?
Yes. And due to A being negative, it's going to open down. Yep.
Can you please send Ishmael to Ms. Bell's office?
I don't think he's here today. He's out.
Ishmael Moni.
He's out. Just come talk to me. Alright. Compression, wider, and it's going to open down because A is negative. Guess they never used the intercom before there. I don't know. Looking at C. C, A, the absolute value of A, the absolute value of 2, that's equal to 2. That's going to be greater than 1. So when the absolute value of A is greater than 1, that is a stretch. And stretches cause your graph to be more narrow. And let's see here, A is positive, so it's going to open up. Stretch, narrow, and up. D, I don't see a number out in front here, so what do we have? Yes, -1. So the absolute value of -1, that is equal to 1. Well, when A, or the absolute value of A, is equal to 1, there is neither a stretch nor a compression, which means it's not going to become more narrow or wider. This is negative, so it is going to open down. So just neither and then down. That's what you should have said. Now, looking at number 3, we are going to have to graph. The directions say, now that you know that the graph opens, should say opens up or down, any stretch or compression, and the location of the vertex, graph each of the following equations. Please include at least 5 points. So we need at least 5 points for this. Now, before I go and start graphing A, we've already worked on A a little bit. We know that the vertex is located at 4, 9. Now, a lot of times in class we have graphs that we go up to 10, and we go out to 10, and we go down to -10, and we go out to -10. And usually a graph this size can catch what we're trying to do. But that's not going to be the case here. 4, 9, 4 is going to be about halfway to where we normally go. That's not an issue. But when we go up to 9, we're almost at the ceiling of where we're at. And this parabola on A, does that open up or down? Up. Opens up, 1/4. That's positive, so it opens up, meaning almost immediately we're going to fall off the graph. So if we go out 10 and up 10 like we normally do, we're going to be off the graph almost immediately. So the way we combat this is we're going to take our x-axis and make it the bottom part of the visible graph that we're looking at, which is going to allow us to see more of this up top here, which is where the action of our graph is happening. So I'm going to get my ruler. I'm going to put my x-axis down here toward the bottom. I don't want to screw this up. Alright, so there's my x-axis. And let me get my y-axis as well. I'll just put the y-axis in the middle. Put the y-axis kind of where you normally do. Okay. This is going to be a bit wider of a graph. I'm going to go by 2 in every direction. I'm going to go by 2 in every direction. So 0, 2, 4, 6, 8, 10, 12, 14, 16. That ought to get it. -2, -4, -6, -8, -10, -12, -14, -16. There you go. And then in the y direction again, by 2 again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. That ought to get it in the y direction. Now if we're going to graph this and we have 5 points, I'm going to get a t-chart going. X and y. If we're going to have 5 points, I need to know what those points are, so I'll get a t-chart going here. We already know one of those points. What's the one point that we know, class? Anybody know?
4, 9.
4, 9. It's our vertex. So 4, 9. Go ahead and plot 4, 9 on the graph. I'll do it the same up here. 4 is here. Up to 9, so that's 4, 8. Remember, I went by 2, so this is 10. 9 is halfway between 8 and 10. About right there. That is going to be 4, 9. Right? Now I can choose anything I want to for x. There is no limitation on what x can be. I'm going to choose x equals 0. Why did I choose x equals 0? I don't know. I had to choose something, so I chose x equals 0. could have chosen 5, could have chosen 8, whatever. So let's all take 0, and let's plug it in for x. It looks like this. Y equals 1/4 0 minus 4 squared plus 9. So take a moment, plug in x equals 0, find out what y is. Zero minus 4, that's negative 4. Negative 4 squared is 16. 1/4 of 16 is 4. So all this boils down to 4. 4 plus 9 is 13. So when x is equal to 0, y is equal to 13. Let's go ahead and put that in our t-chart and plot it. 0, 13. So everybody take a moment and plot 0, 13. 0 on up to 13. There's 12, 14, 13 is about right there. Now if you recall, there is a non-visible vertical line that always passes through the vertex. What is this? The axis of symmetry. Now the axis of symmetry is a line of symmetry that kind of divides our parabola exactly in half symmetrically. So however many units to the left you go, there is a corresponding point on the right side. So for example, how far to the left of the line of symmetry did we go?
4.
Yeah, we started at 4, we went to 0, so we went 4 to the left. So let's go 4 to the right, which takes us to x equals what? X equals 8. From 4, you go 4 to the right and you get to 8. So we're going to go up to the exact same point, which is right there. 8 comma what?
12,
13. It's the exact same y value. So if you are equal distance to the right or left from the line of symmetry, you'll be at the same y value, the same like height. All right, let's choose something else. What do y'all want to choose? Let's go a little bit further to the right. Let's not go too far, but what do you want to choose? A little bit further. All right, 10. I heard 10, I think. So let's plug in x equals 10. It looks like this. Y equals 1/4. Plug in x equals 10 minus 4 squared plus 9. Go ahead and solve that out now. When x is 10, find out what y is. Ten minus 4 is 6. 6 squared is 36. What's 1/4 of 36? 9. So that becomes 9. 9 plus 9 is 18. So when x is 10, y is 18. When x is 10, y is 18. Let's put that on our t-chart. 10 comma 18. Go ahead and plot that point. 10, 18. How far to the right are we from our line of symmetry? You can, yeah, 2, 4, 6. We are 6 units away, right? From 4 to 10, that's a distance of 6.
Oh, crap, we went to 10, not 4.
Yeah, 10. So we're going to go how far to the left? 6. 2, 4, 6. And right here is the symmetric point that we just to the point that we just plotted. So it's like the reflection of the point that we just plotted. What is that point?
2,
Negative 2, what?
10,
18. They always have the same y value. Once you got your 5 points, go ahead and connect the dots.
You have to do 5.
Yeah, I should do 5. Part B is very similar to that. You need to identify the location of the vertex, figure out if your graph opens up or down, and then focus on whatever quadrant the majority of your graph is going to be in. So this one, a lot of it was happening in quadrant 1, some in quadrant 2. I'm going to flip to the back real quick. I know the folks in class haven't quite gotten this far yet, but for the sake of the video, I'm going to keep going. I didn't quite do the other classes like this, but it'll be all right. Let's take a look at number 4. Number 4, I give you a graph, and I tell you to find the equation of the following graph. There's a few key points here. One key point is right there. That is my vertex. So everybody look at that. See if you can figure out the location of the vertex. Don't shout it out, but write it down. Where's that vertex located? Negative 2 what? Negative 2, negative 1. That is the location of the vertex. Once you know where the vertex is, you can write this out in vertex form. Y equals, I don't know A, so I'm going to write A. I'll find that in a moment. Parenthesis, X. See if you can figure out what goes next. Don't shout it out. What is it? X plus 2, because remember it's x minus negative 2. When you subtract negative 2, you have to add. So x plus 2 squared minus 1. So we have our equation in vertex form, but we need to find A. So here's how we're going to do this. We're going to find a point that our parabola passes through, and I don't want this point to be the vertex, nor do I want it to be a 0. It doesn't really affect us here, but it might affect us in other problems. So it's good to pick another point if possible. And there's a pretty clear-cut point right up there. So look at that point. See if you can figure out what that point is. What is it?
0.
Yeah, it's 0, 3. 0, 3. 0, is that an x or a y value here? It's an x value. 3, x or a y value? Y. We have an x and a y value. I've got an x and a y down here. What am I going to do with 0, 3? Plug it in. So y is 3. A, still unknown. X is 0 plus 2 squared minus 1. All right, I would like you to solve for A. Take a moment and solve for A. Zero plus 2 is 2. What's 2 squared? 4. So we get 3 equals 4a minus 1. We then add 1 to both sides, plus 1 plus 1. We end up with 4 equals 4a. 4 multiplied by something is 4. What is a? A is 1. So we're going to use that to write out the equation of this parabola. Y equals, A is 1, so I don't have to actually write 1. I can just write x plus 2. It is understood there is a 1 there in front. I don't have to actually write a 1. Squared minus 1. So there is the equation of the parabola seen up above. Okay. Number 5 is done in a similar fashion. You need to find the location of the vertex like we just did. Write out the equation in vertex form, leaving A as an unknown. To find A, you find a point on the graph that the parabola passes through. Plug in the x value for x, plug in the y value for y. You then have a one-variable equation that you can use to solve for A. Once you have A, you then have the equation of the parabola. So again, 5 is very similar. All right, for the last part of the video here, in about 1 minute, I'm going to identify the location of the vertex. If you'll remember, vertex formula is x equals negative b over 2a. X equals negative b over 2a. For a here, I got to identify a, b, and c. What is a on 6a? It is 1. What is b? It is negative 9. Got to pay attention to those signs there. And c is what? 8. We don't actually need c to find the vertex, but it's good to know what it is. So x equals the opposite of b, which is negative 9. No. It's the opposite of, yeah, it's positive 9, right? Sorry about that. Positive 9 over 2 times a, that's 2 times 1. So we get 9 over 2, which is 4.5. That's the x value at the vertex. That's half of it. To find the y value of the vertex, who knows what to do? Plug in 4.5 for x. So y equals, instead of x, 4.5, we got to square that, minus 9. Again, I'm just looking up here at this equation. Multiplied by x, which is 4.5 plus 8. Now this is where a calculator comes in handy. I always try to go without a calculator whenever possible, but calculator just comes in real handy here. So plug this into the calculator to help you out. I'll be doing the same thing, so look up front to see if you got it all right. .5 squared, that becomes 20.25. Negative 9 multiplied by 4.5, that's negative 40.5. And then plus 8. Go ahead and combine all that. And I get negative 12.25. What were we finding again? Y where? At the vertex. So the vertex, let me write the word vertex here. The vertex is located at 4.5, comma, negative 12.25. Close parenthesis. That is what we were looking for, the location of the vertex. So you do the exact same thing there on 6b. Last one I'll do for the video, factor the following quadratic functions and identify the zeros. Remember, when we are factoring, we want two numbers, I use m and n, two numbers that multiply together to equal what in this scenario here for a? Oh, you can't see? So on 7a, two numbers that multiply together to equal what?
Equal 9.
It's the constant. It's 8. So two unknown numbers that multiply together equal the constant. And this works when the coefficient of the square term is 1. And those same two numbers, when I add them together, m plus n, they equal negative 9. So the product is positive, but the sum is negative. What do you know about the signs of m and n? The product is positive, but the sum is negative. Yeah, they're both negative. So negative 8 multiplied by negative 1, that's positive 8. Negative 8 plus negative 1, that's negative 9. So the factors are going to be this. Y equals x minus 8 multiplied by x minus 1. So that is how you factor. Nope. All right, and now we need to find the zeros. Remember, we've got a binomial multiplied by another binomial. When you're multiplying two terms, if one of the terms is 0, then the entire product is 0. So in other words, if I can make that binomial equal to 0, 0 multiplied by anything becomes 0. So what does x equal to here to make this binomial equal to 0? X equals positive 8. 8 minus 8 is 0. Same thing here. If I can make this binomial equal to 0, 0 multiplied by anything, the entire product will become 0. So what value for x makes this binomial equal to 0? X equals 1. So we have zeros at x equals 8 and x equals 1 after we factored and got y equals x minus 8 multiplied by x minus 1. All right, very good. I'm going to go over the rest of this tomorrow in class, and I will post a video tomorrow afternoon so you can finish that. People that are in class right now, we got 15 minutes to go, so please don't pack up. Keep working on this.